Hello, Programming One, and welcome to my attempt at ensuring that you still get a decent programming class experience, even though I am not there. Now, on last Friday, we did a good amount of practice using our new for loop skill. And if you were absent on that day, I have posted to YouTube um, basically that entire class, although I cut out all of the waiting parts so that you could do your work on that. Now, at this point, we're going to go ahead and move on to the fraction quiz. And I'll say here in advance that for the substitute, they're basically going to be doing the same thing they did in programming 2 if you are in fact the same substitute. And please keep them attentive and off of their phones. I would recommend that maybe halfway through class, or actually, if this is third period or fourth period, I mean, then they have lunch halfway through class, which is a good break. And if they are fifth period, I would ask that you please give them a few minutes break uh, in order to kind of recoup their senses there, because copying this down for a long time can be difficult. That said, they really do need to pay close attention and stay off of their phones. Pay particular attention to, well, I guess it's not really fair of me to call those people out directly, but you'll notice that in fourth period, if you look to your left substitute, you will occasionally find people on their phones or playing games. And if you're in fifth period, if you look towards um, the second middle row, and by second I mean the first being closest to you, you will also find people have a tendency to get on their phones. Um, and I would recommend for the students there that you do not do that, because I am telling the substitute from my little God position here on the internet to give you a break in the middle of class. I will also state for the substitute that just like in programming 2, if the students request that you pause this instruction at any point, that is fine. Um, and if they do not get through this entire video due to pausing, that is okay. However, if you notice that students are not paying attention and then also asking for you to pause the video, feel free to ignore them. Their suffering will be brought upon them by themselves. All of that said, that sounds really gloomy. Let's get started. So, by accident, we had made this fraction quiz thing uh, a little early, but now it's actually time to do it. So, or no, it's not fraction quiz. It's pyramid time. It's even more interesting than that. I'm a huge mess. So let me go ahead and actually open up the correct thing, because we're not doing the fraction quiz right now. So you'll notice that I had that open. And you guys can just do that. Note that I'm making a new project. You're not making a new project, kids. You are going to be working inside of your control practice, but I'm working on my home computer, and so I don't have that project in existence. So let me go ahead and open up. I'll just go do this window. And so control practice, I'm going to make a new class. Once again, you are not making a new project. You're sticking in the old one, and we're going to make a functional pyramid. And I will be grading this, though, just so that your attentiveness is somewhat guaranteed. Okay, let me get my notes up and ready to go for the pyramid. So the last thing we did in control practice, and mine is blissfully empty. Whoops. But let's go ahead. Oh, did I even hit the record button? I did. Good. Whew, I'm a mess. I just finished recording for programming 2, and it's a lot to think about when I don't have you guys asking me questions and whatnot. So first thing I've got to do is add main. You guys should already have that. Now you're going to be using main to test your work and make sure that it's actually functional. So control practice, boop, and oh, I put equals control practice equal new control practice, ex dot well, we're not going to do anything with it yet. So you guys would have all kinds of methods up here in the top. The last one we did was the sum odd n, in which you calculated the sum of all odd numbers between 0 and n. I'm going to go ahead and ask that you start class off today by writing the opposite of that. I want you to make a public void sum or sum even n, and just like this. And using your skills from last time, I would like you to go ahead and write me that. So it should start at n, which will have to be taken in as a parameter. Note that I didn't write that there for you. And so it's gonna start going from 0 to n, and every even number should be added up. And so the output should be the sum of all even numbers between 0 and n. Not every even number between 0 and n, the sum of every even number between 0 and n. So I should be able to go ex sum even n, and it should print out what I want. And I want all of you guys to make sure you test this when you're done. So I'd ask the substitute to go ahead and pause the video here, and let's give you, I don't know, 10 minutes is too well, yeah, why not? 10 minutes. Take 10 minutes, write this. Oh, and if I'm going to give you 10 minutes though, let's not look at sum odd n. Let's try to minimize that. And for the substitute, to see if it was minimized, they'd have something that looks a lot like this right here, except it would say sum odd n. And there's this little minus button off to the left side, and every single one of them should click that so that it minimizes itself to this nice, tidy little single line thing. That'll make sure that they actually have to exercise their brains a little bit. Therefore, they should actually deserve 10 minutes. So give them 10 minutes here to do this, and I'm going to go ahead and continue on. So pause it, and I'll assume you just finished pausing it. So here is the way this should look. I'll note that they could also say sum equals sum plus I, but I just want to say sum plus equals I. That is the shorthand for that. And then we're going to jump down to the end of our for loop and system.out.println, and we're going to print out sum. That is our warm-up exercise for the day. Hopefully that worked out well for you guys. Okay. So I'm going to go ahead and minimize this method as well and jump down here, and we're going to learn how to draw a checkerboard. As a matter of fact, I'll even show you here if I put 9 in there and go ahead and run this. I'll go ahead and assume that that's actually correct, that it gave me 20, but go ahead and delete that. All right, so I need to have you import some stuff. So for those of you who are a little slow on this, please pay very close attention. Top right corner, project structure. It's the folder with the 3 blue squares. Click that. We're going to go to modules, then dependencies, then this little plus button on the right side. You are choosing jars or directories. Now, most of you should have these files saved to your desktop. Mine are on a completely different drive in my computer, so I'm going to grab those, and then I'm going to apply and hit OK. I don't know if we're going to need the dialog jar yet, but we might actually get there. So now, let's actually get to work. So for our checkerboard, let's draw a checkerboard. but we need to actually add our import first. So let's go ahead and import acm.program.graphicsprogram. An easier way to do this, for those of you who are now madly typing, would just be to go to the end of control practice and say extends graphics program. At which point Java or IntelliJ is going to say, hey, wait a minute, you're missing an import. And if I go over to this light bulb, I can click on the drop arrow and click import class. I could also click on this red part, press Alt Enter, and then hit Enter. And now that class has been imported. Super useful. But if you want to, you can just type out the import up here at the top. Don't be afraid to ask the substitute to pause, but substitute, don't pause for too long. Okay. Now, let's do a private void draw checkerboard. Now, we know, of course, that we are going to need to write a for loop because we don't want to have, so first of all, let me drop here. A checkerboard would probably be made up of G rectangles. So let's go ahead and import acm.graphics.grect as well. And then drop back to draw checkerboard. So one way to do this, and it would be a really sucky way, would be like grect r1 equals new grect. And say, I don't know, it's 50 by 50, use the size. And I would add R1 at 10, 10. And then I would do grect R2, except the problem with doing it this way becomes readily apparent. How many squares are there in a checkerboard? It's an 8 by 8 square, so 8 times 8 is what, 64? That's probably not right. I'm going to go ahead and check myself before I wreck myself. 8 times 8 is 64. Apparently I can still do my times tables. So you would have to do this process 64 times. And on top of that, you would have to add it in exactly the right spot each time. That would suck. So we're not going to do that. Instead, we're going to draw a checkerboard the smart way. We're going to write a loop, and our code is going to be clever enough that this thing will just draw its entire self. So, for, of course, int, and now we could use I, but let's think about this first of all. And, you know, we haven't really talked about this, but I'm going to go ahead and take a second to do that now. The double slashes, which you've seen me do several times, that's a comment. There's a lot of different ways to do comments in Java. A double slash is for a single line comment. Slash star and then followed by enter will create a star slash. So this is a multi-line paragraph comment. And we also have the ability to make a comment which gives us a description for our method. So I can do slash star star and then hit enter. And this one's really cool because I can say that this method draws a checkerboard using for loops. And then minimize this. And then if I go down here and I say ex dot draw checkerboard and then hover over draw checkerboard, you can see in that little box that my description of draws a checkerboard using for loops is right there and sticks around. So those are different ways to make comments. Just to be clear with you, we'll worry about those later, but for now, I just want you to know exactly what those are for. They're mostly for documenting our code. It makes it more understandable what we're doing. I use them to write notes to you guys and give instructions, but documenting the code is important. So let's keep track of a couple of things here. Checkerboards are 8 rows by 8 columns. So checkerboards are 8 by 8. We can break them down into rows of 8 and columns of 8. Okay, are you with me? Hopefully you're with me so far. Can't exactly take a question in my current state. Then So checkerboards are 8 by 8. We can break them down into rows of 8 and columns of 8. Another trick, though, is every other, every other square, I guess we could call it, has a different color, because I'm going to let you customize the colors of your board, although normally it'd be white-black. And that's, this is a definition of a checkerboard, like what a checkerboard is. So how am I going to handle writing a loop which can draw a checkerboard? Well, first of all, I can do for int, and then normally I would say I equals 0. But the thing is, I told you before that usually it's I, but not always. So actually, this time I'm going to call it row. So starting at the 0th row, as long as row is less than 8, so maybe these are actually a 7 by 7 board, and then row plus plus. I have to look up how many squares are in a checkerboard really quick. Whoop. How many rows in a checkerboard? Looks like my video for programming 2 just finished uploading. There are 8 rows, so there are totally 64 squares. Oh, but it's because we're starting at 0. Duh. Monkey brain took over there. Because we start at row 0, and we start counting from 0, 0 to 7 is still 8 rows. So that's why we're doing less than. You could do less than or equal to 7 if you wanted to. Now, what are we doing for each row? Well, let's say that for a checkerboard, what is that? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, I'm not actually going to do all of these. So anyway, let's say that this is a row, and, well, it's not going to let me select that. That a column would be this, right? So row, column. So rows are horizontal and columns are vertical. So what do I do now? So do I do for each row and then just draw 8 squares? So, but the problem with that is I'm back to having to do this eight times, right? So to do this, I'd have to draw this 8 separate times. That, honestly, that really sucks if you think about it. So what can I do? Well, I can put another loop inside of the first one. So I can do for column equals 0. Oh, int col, sorry. For int col equals 0, as long as column is less than 8, column plus plus. This is a process referred to as nesting loops. Now, whenever you nest a loop, I know some of you are going to be really screwed on square brackets. Now, this is going to be really difficult for you if you have errors because you put a parenthesis in the wrong spot or you put a semicolon here. So really think. Of course, a for loop can't end with a semicolon because if it ended with a semicolon, then you couldn't give it a body. And if you couldn't give it a body, the loop wouldn't even do anything. Same thing with an if statement. So they have to have these opening and closing curly brackets. And each loop has to have the opener and closer because you need Java to know where that for loop's body is so that it knows which stuff to repeat on that for loop. Now, the way we've written this here in the nest is actually to say that for every single time the outer loop runs, the inner loop will run all 8 times. So in total, we're going to get 64 iterations of this loop. Whenever we do this nesting feature here, where we put a loop in a loop, and if we really wanted to, we could put a loop in a loop in a loop, make a 3D checkerboard, although I wouldn't know how to display that using G-rectangles, if I'm being honest. You can nest as many times as you want. The thing is, when you do this nesting thing here, what you'll have is n squared repetitions, where n is the number of items in here. Okay? But you don't need to worry about that too much. All you need to know is the outer loop is going to run once. That means this inner loop has to run all 8 of its times. It doesn't run once, then run once, then run once, then run once. Okay? Once, 8 times. I just tried to select that. 8 times. Twice, 8 times. Okay? I think you get it. So what do I actually want to do inside of my inner for loop? So I don't need to actually do anything in here in my outer loop yet, except for to run this loop. So we're going to basically think of it like this. We're going to fetch one row, and then along that row, we're just going to draw 8 blocks. And we're going to do that with a loop. So let's refer to each piece of the checkerboard as a tile. So we're going to make a grect tile. I'm going to say tile is equal to a new grect. I'm going to do 40 by 40. And then if you remember back to when we did the house, we store the tile's position into some doubles, and then we add the tile at tile X and tile Y. So this is actually fairly straightforward, right? So this looks a lot like what we did with the house. Except because we put this set of instructions inside this loop, it's going to happen 8 times. So we're going to create 8 new tiles. The only caveat here is that as we create the tiles, the name tile is going to get assigned a different G-rectangle over and over and over. And as that happens, we won't be able to refer to the old tiles anymore. Now, for this particular problem we're trying to solve, that doesn't matter, but you do need to be conscious of it when you do something like this where you're looping, because at each iteration of the loop, tile will be talking about a totally different G-rectangle, and we need to keep that in mind. Okay, because tile is just a reference. We're just using it as a reference for what's on the other side of the equal sign. If you're in 5th period, this is that trash can analogy all over again. All right. I really need to get a cardboard box for that. Anyway, so tile X position. Where would I want to put it? Well, let's start by, let's say we want to center the checkerboard overall. So we always want to start by saying get width divided by 2. That's the center line of the entire window, right? And then we want to subtract. So because we want to draw the checkerboard left to right. But how far over do I need to go? Well, I need to go over a certain number of tiles. So if I'm in the middle of the board, and the board is an 8 by 8 board, so 1, 2, 3, 4, 5, 6, 7, 8. All right, if I'm in the middle of the board, somewhere right around here, how many tiles do I need to move over to be on the edge? 1, 2, 3, 4. Okay, easy enough. So I subtract tile.getWidth times 4. And that moves me to the left edge of the checkerboard. However, if I just did this, then every single tile will draw in the same spot, because look, get width. Does the value of remember get width is the width of the window that appears when we run our program. Does the value of get width ever change? Well, unless I drag the sides of my window around, no. No, it doesn't. How about tile.getWidth? Does that ever change? Nope, it's always 40. And then 4 and 2 obviously never change. So if I did this, all of my tiles draw in the same spot. So I need to change this number, so whatever this blue section evaluates to, I need to change that by a certain amount to ensure that my tile will end up in a different spot each time the loop runs. Okay? So let's add something. Now, inside of this loop here, what do I have that changes every single time? Substitute, please pause the please pause this for a minute and let students think about it. And by minute, I mean like 30 seconds. Okay, so the only thing we have right now, there's actually two things we have that are changing, but the one that we're going to worry about is call, because column changes every time this loop runs. And since it changes, we can use it to put the tiles in a different spot so that every time the loop runs, we'll have a slightly different spot. So we're going to use column times tile.getWidth. So what'll actually happen here is the first time the loop runs, we're actually going to put the tile right here. Why? Because column will be 0, and 0 times anything is 0. So we're not actually adding anything. But then the second time we run, column is 1. So we're going to put the tile at this blue part plus 1 tile width. So it's going to move over. And then we'll do it for 2 tile widths over, and 3 and 4 and 5, all the way up until we do 7 whole tile widths over. Not too bad. Okay, how about tile Y? Well, tile Y is not too bad. And I don't know why I really put this in parentheses, because I don't need to, so I won't do it this time. So this time, of course, we want to get height if we want to center the checkerboard, and we divide it by 2. And then we subtract tile height times 4. And that's supposed to be tile.getHeight. I'm getting ahead of myself. And then we're going to do the exact same thing, except this time, what do we have that represents the change in vertical distance? Column doesn't work anymore. Row does. Row is keeping track of the vertical. So we put row times tile.get height. And there we go. So now this isn't going to completely draw the checkerboard because we're not handling coloring in stuff yet. But let's go ahead and actually do this. So if I come down here, I need to actually, I can't say draw checkerboard like this. Let me zoom back in. I'm going to need to say ex.start, and I'm going to need to give an init method. So I'm going to go up towards like the top of my program. Now, for those of you who frequently get stuck, please be careful. I've gone to the top of my program. You don't necessarily have to, but you're not allowed to put a method inside of a method. So be very careful where you're writing. We need to be in the class. So it has to be in between this opening bracket and this closing bracket. I'm going to do public void init. And just like whenever we make init, we're going to override it. Whoa, that is not what I wanted. Sorry. Override, like this. And inside of init, we're going to call draw checkerboard. Now, because we're inside of the class, I don't have to say ex.drawCheckerboard. I just have to call draw checkerboard. Once I've done that, if I hit play, I see that I've got all of my bricks exactly where I want them to be. Well, that's cool. Let's make it even cooler. I'm going to show you a little trick you can do inside of a for loop. Actually, I can do it after the add part. So I'll go right here after we say add in the loop. If I write pause, because as it turns out, there's a pause method inside of graphics program. If I write pause and then pass in, say, 100, now this is measured in milliseconds, so that's a tenth of a second. If I run my loop again, look at that. Now it's animated, which is always fun. There's my checkerboard. So I like that. But now, before I add these tiles, I need to decide which ones are going to be black and which ones are going to be white. Or, you know, whatever color you guys decide. But how can I do it? That's something I would like for you guys to try to figure out. Now, for fourth period, we have a TA who could assist. But for fifth period, unfortunately, we do not. And that means we are going to need those who catch on early to try to help out their classmates. So what you need to do here is decide whether or not to color the tile. And then in case you've forgotten the way you color a tile, you would say tile.setColor, or rather set fill color to color.black. Actually, it's supposed to be black, like that. And then you do tile.setFilled to true. So you'll need these two lines. Now, of course, if I do this, all tiles will be black. Right? So that's a problem. Instead, I need to use an if statement where I have a condition such that every other tile will be blacked out. Let's see if you can figure this one out on your own. And even if you don't figure it out on your own, that's okay. Because, and I'm sorry, I'm just checking to see how long we've been going for. Half an hour here. And that's okay, because sorry. There's a reason I'm not in class. Okay, so and that's okay if you don't quite get it. But I'll give you a bit of a hint that you might want to be able, or actually, you know what? Let's see how would you get every other tile. We've already done something similar to this, but the if statement's not quite so simple. See if you can figure it out. And substitute, you could go ahead and pause here. And then assuming you're no longer paused, I will go ahead and continue with how this works. So pretty simple. If we are looking at an even row, if we're looking at an even row, then which tiles are colored black? Well, if the row's even, then it's all the odd tiles, as it turns out. And so we go ahead and put this here. However, if it's an odd row, then it should be all of the even ones, just like this. And now, running my program, I get an actual checkerboard. A common mistake is to only do every other tile across the whole board, but you have to remember that a checkerboard alternates. You might want to pause for students here to copy this and wait till they're all caught up before resuming. Okay, so now assuming that we've started back up, I'm going to minimize this draw checkerboard method. Boop, just like that. And then what I would like students to do with the remainder of class time is to make a private void alt draw checkerboard, wherein I want them to draw a checkerboard, but instead of doing it from rows across, I want them to do it from columns down. So it's very similar, very, very similar, but I want you to switch the way it draws. So instead of drawing like this, I just realized I don't have alt draw checkerboard on this computer, so I can't show you. Instead of doing it across like that, I want it to draw top to bottom. Very similar, but top to bottom. So that's what I would like you to do with the rest of your class time. Thank you guys for paying attention. And once you've finished, you may, use your phones and stuff, but you may not get too rowdy. I don't want to be Obama sitting on the edge of the desk in the Oval Office. If you're not aware of that meme, I'm sure you can look it up. All right. I will see you hopefully on Thursday. Thanks, guys.